Most probably all of you know him and actually use most of the tools that he have already developed. He's the main developer, CIO, CTO of Lmod. And he's going to talk about Lmod and XALT. He's coming from TACC. How was the jet lag this morning?
Yeah.
Good. Okay, thank you so much.
Thank you. So I had this little project that I'd start working on, and I figure I'd be done in a couple weeks, couple months, and it's been 9 years that I've been working on Lmod. And XALT, actually, even though you're not fully aware of it, it really is a follow-on from Lmod. So they're really one project. I just have two names. So outline, I'm going to talk about environment modules, why they're a cool thing. I didn't invent environment modules. I just have my own implementation. I'm going to talk about what is Lmod in case anybody in the room doesn't know what Lmod is. And I'm going to spend most of my talk about, at least in the first half, about how Lmod can help manage your site, or the changes that have happened over time in response to the mailing list and GitHub requests and stuff. And then if I got some time, I'll talk about advanced topics and where you can get more help. So what are modules? So modules help users load the software package they need, MPI, Boost, PETSI, whatever. Modules can be unloaded. This is the really nice thing about modules that have the advantage over shell scripts is you can reverse what you did. Modules are in one file and not one for each shell. So like if you do the Intel compiler, you have to source one for bash-like shells and another one for C shell. And if you're a fish user, you're out of luck. Modules are the way we as administrators talk to our audiences. And it's the way we think about packages. Packages and modules, for the most part, go together. This program, Lmod, is really only doing one thing. All it does is change your environment. It adds to the path, it sets some environment variables, it sets an alias, and that's it. You know, I think it's a really simple thing. How hard can this be? And I've been at it for 9 years, so it maybe says something about me. And, you know, that's what it does. So what's Lmod? Lmod's a replacement for the one that's been out there for years. I call the original environment modules Tmod to contrast it with Lmod. So if I say Tmod, you know what I'm talking about. And when I say Tmod, I mean both the TCLC version and the pure TCL version. Their work on the TCLC version has pretty much stopped. There hasn't been a new version since 2012. There's a guy in France who's picked up the pure TCL version and started to make modifications. The guiding principle is we're trying to make life easy without getting in the way. And I will probably say this a couple times. Lmod reads TCL module files as well as Lua-based ones. There'll be another phrase, but we'll all sing that at the end. So what are the problems that modules are trying to solve? Packages are created and updated all the time. Some users want new features. They want bug fixes, and they're willing to tolerate the new bugs that come with the new software. Other users want stability and continuity. So this way you have the ability to have both keep the new users happy and the one that wants stability happy at the same time, because you can have more than one module available, more than one compiler, more than one MPI stack. Well, this next statement may not be true. I still have 55 minutes. I'm going to have 55 minutes until I'm done. Okay. But no system can install all versions of everything, so you got to limit what your choices are. The real problem is that user programs pre-built with C++ or Fortran, or user programs using pre-built libraries that are in C++ or Fortran must link with the same compiler, i.e., you build with PGI, you can't link with Intel or GCC. Similarly, MPI applications must be built with the same library, same MPI stack and compiler. So this last two part represents one of the biggest problems with the original design of modules, the proliferation of versions. So here's an example of what Lmod can do, and we've all hopefully, how many people are using modules? How many people are using Lmod? Okay, so most of you. Here, you can load some modules, you can unload, and the cool part that Lmod does, if you use the hierarchy, it'll unload modules that are no longer seen. Though, like if you unload GCC, you can't load the MPI stack or PETC, and it tells you you've got inactive modules. You load a compiler, it'll reactivate those two modules using the new versions. You can swap, you can actually load them back. So this is what we do at TACC, and it's very convenient. This shows module avail, and it shows it in a hierarchical fashion. So at the top shows modules that were PETC and Parmenas and stuff that were built for the Intel and MPICH 2. Then there are the compiler modules, and then there are core modules. So this is the way that we typically run this. This is using a hierarchy. The other phrase I want to get you to sing along with me is that Lmod will run flat layout as well as a hierarchical layout. There are some advantages to the hierarchical layout, but you don't have to do that. So we're all Unix heads. We've been doing this for a long time. So everybody ought to be shocked that modules actually works, because we know that a child process can't affect the parent's environment. So you run a command and you change your environment. How could this possibly work? So the trick is that Lmod's a program that generates text. Export path equals, or just find an alias. What happened to my mic? Still here? Can everybody hear me in the back? Okay, don't worry about it. Huh? Yeah, I like walking. So the trick is that all right. This way, huh? All right. The trick is that Lmod generates text, and then that text gets evaluated, and that's in your current shell, and so that's how it defines the environment. The other point is that standard out is what gets evaluated, and standard error is passed through. And I'll talk about the ramifications of that later. So how can a tool like Lmod improve the user experience at your site? Sites provide packages. Users pick the ones they want. But what we're really after is cutting down on tickets. We'd like to have a system that runs smoothly and generates no tickets. Now, that doesn't happen, but we want to cut down. Any place we can cut down on tickets is a good idea. Or we just want to make the site easier for your users to use. So, as I said, I've been working on Lmod since I worked at TACC for 9 years. It was first released in 2009. It's the only module system we use at TACC, even on our Cray. And this is some examples that Lmod can help. And a lot of this dialogue has come up from the user mailing list. So what I call the user local bin problem. What happens if you have your startup scripts define user local bin in your path? So every user gets that. And then some module out there, bar, also defines user local bin in the path. So if somebody loads it and unloads it, all of a sudden user local bin is no longer in your path. And this could be, for us, our Slurm stuff and other things end up in a user local bin, so this can be disastrous. So you've got one, and then a second choice is coming along. Lmod supports duplicate paths, so you can have multiple copies of a path in there if you configure it that way. Or I'm going to add reference counting just the same way as the pure TCL Tmod does. so that it'll remember that you had 2 copies of user local bin, and it would count them down, and only when it gets to 0, remove it. So, same module. So, there are a couple things that Lmod does that tries to protect the users. The same module is an issue, so in TCL and Tmod, unless you add something to your module files, you can load 2 versions of GCC. And then if you unload one of them, you might wreck the performance. You know, it gets confusing, and you can get in weird situations if you allow 2 modules of the same type to be loaded. Normally, Lmod will unload the old GCC and load the new one to replace it. So this is, you can with Tmod put a conflict in there to prevent that. But also, Lmod prevents you from loading 2 compilers or 2 MPI tags at the same time if you add this feature, what I call the family directive, which says you can only have 1 compiler or 1 MPI stack loaded. Experts can get around this case, and there are issues you can handle with GCC. Okay. How do you manage software, old or new? How do you test new software, or how do you deprecate software? So, sites typically have 2 choices. We at TACC, for the most part, store our software locally to the disk or SSD. But no matter how big your SSD is or how big your hard drive is sitting out there, it's never big enough. But other sites, or if you use a shared location, that's fairly infinite. You can store lots of versions. But how do you encourage your users to use new software without breaking old job scripts? Plenty of sites that do bioinformatics and people like that want to have software for the life of the machine. But you want to encourage your users to move toward the newer software as the machine gets older. So Lmod now supports hiding regular modules from Avail and Spider, so that you can say the old version of Bowtie that's 2 years old doesn't show up at Avail, but somebody's old job script will still find it. Hidden modules can still be loaded. Modules can be, there's a place where you can explicitly mark modules to be hidden, or there's now thanks to a user of Lmod, there's a isVisible hook, so you can have a programmatic way to say, based on file name, location, module name, that you can actually program and say, okay, all these modules that are 2 years old are hidden. And both users and sites can hide modules from themselves. Okay. Before I go on, there was one topic I wanted to briefly talk about, and that is caching. So one of the features that Lmod supports is properties. You can mark a module as being PHY ready, or mark a module as being experimental, or mark a module as deprecated, or whatever you want properties to be, or you can specify this is chemistry, this is biology, this is something. The problem with that is that that information is stored inside the module file, which means Avail needs to look at all the modules. Is my talk over now? Can I sit down? Well, the time's going down. Okay. Oh, right. So properties are a great idea, and they're a really terrible idea because Avail requires to know the contents of the module file, which means so Avail is walking your module and essentially loading every one of them to see if a property's been set, because there's no way for me to know. And there's no way to remember that information, and I can't tell when it changed anyway. Well, except that Lmod supports caching so that it can read one file instead of reading hundreds or thousands of files and walking a directory tree. So caching is, can speed up things greatly. Now, on an SSD, who cares? It's so fast, it just doesn't matter. But on parallel file systems, which you think would be fast, but they're really not very, as we all know, they're not very good at reading lots and lots of little files. That's expensive. So, Lmod supports caching. Lmod supports, so that speeds up Avail and Spider. What I normally don't do is loads which don't have to read all the module files, but it does have to walk the path, doesn't use the cache file because that's for safety. But if you've got a slow file system, you can tell Lmod to use cache loads, and so it'll read that one file and use that to pull the module file. And that's great. The big disadvantage, of course, is that if you don't keep the cache file up to date, you won't find things. So that's the trade-off. That's why I don't make it default. Okay. Deprecating modules. Say you're like us and you've got limited space, you can only keep a couple versions. So how do you decide what packages to remove? Well, Lmod supports tracking modules. So you can track your usage across the system, and you can know that, oh, this compiler's being used and this one's, usage is going down. You can say, okay, these 10, 50, or 100 users you can send a targeted email to them because you know which users loaded which modules, and you can get counts, and so you can have targeted messages. The other thing is, independent of tracking, you just know you want to get rid of a module, you can have a nag message that says, okay, this module is going away on such and such a date. So, and we have found by counting by knowing who's using what and targeted email and tags to be very effective in terms of getting our users to move. They don't move quickly, but you yell at them enough, they finally get the message. And the way it works is every time a user loads that message, they get the message with red barriers around them saying, this module is going away. So this was counter to the way I think about things, but it makes a lot of sense for certain sites. Suppose your site produces weather forecasts or is processing satellite data, image data, and you need to do this on a regular basis. And you do not want the software underneath to change things. So is everybody familiar with the concept of defaults, module defaults? So some of you. So Lmod, well, all module systems, Lmod in particular, will pick the default. So if you say load the Intel module, you get what the system says is the default, which can change over time. And a site doing production may not want that. So a particular user asked me, can I require users, can I have no defaults? And so yes, you can set Lmod exact match equals yes, and there's no default, so the users have to specify Intel /17.4.
What do you mean by change over time?
Well, if you add, so you can have, so if you add a new module, by default, Lmod finds the most recent one. And so if you never change compilers, then no, it doesn't change. But if you add a new compiler and or you mark which one is the default, it does change. And I thought this was interesting. I had this support for a while, but I left the marking of the default. So recently I removed the fact that it'll mark default. So if you say you exact match, there are no defaults marked with Avail. So it's common, or at least we do anyway, to provide a default set of modules, especially since we're using the hierarchy. We define a compiler and an MPI stack, so most of our users don't know that they're running a hierarchy. But we try and give the minimal set possible. Whereas users might want a particular version of Python. They might want some bio apps or some chemistry apps to be in their path. And they don't want to have to do that in their startup scripts, and especially getting it right in the startup scripts in an MPI environment with a hierarchy is tricky. So users can have their own modules at startup, and so Lmod supports a default collection, and users can have as many collections as they like. This is convenient. Collections work in the sense that they remove all the modules that a collection is a list of modules, and when you load that collection, you just get those. So it wipes out all the modules you currently have and gives you a new set. Shared home file system. How many people have a shared home file system? Yeah, you poor users. Lmod, I would say we never do that. But in fact, our most recent machine, for reasons of contractual, we had a shared home file system one time. And this was so I was glad I added it to Lmod so that we could use it rather than having to invent it on the fly. So if you share your home file system across 2 more clusters, and it's very likely they're going to have different modules on them, then you can set Lmod system name to be unique for each cluster, and that will make the user collections and cache files be unique for that machine. Because obviously, one set of modules may not be available on the other system, so you want to have different collections. As I pointed out, the way Lmod works and the way all these environment modules work, the output that would go to the user goes to standard error, which makes it a pain in the neck to grep. So there's a couple choices you have. One, and there's a fair number of sites, I know at least 2 of them in the room, where they set Lmod redirect to be yes. So that says what it does is when it writes out, instead of writing direct error messages to the user, it uses echo statements and does some fancy stuff with the spaces to make sure it survives the eval. This works for Bash and Z shell, but does not work for the C shell variety because there's something weird about that shell. But if you define your system to use the redirect all the time, you lose the pager, and I find that pager to be very helpful. So Lmod normal, the standard error gets piped through the pager if there's a terminal connected. But so instead, when I do need to grep, rather than remembering the 2 greater than and 1 bit, I can, even though it's more characters, I like the fact that I can say Lmod minus minus raw, those are 2 minuses by the way, redirect, show, so that will give me the module IMPI in this pure text, and I can then grep for it. So I find this a convenient hack. Sites want to control the output of avail. So this one is this is sort of the normal output you get where it shows the directories that those module files are. And that may, for experienced users, that's fine. But when you have, we all get new users all the time, and so you have to retrain them. In fact, we're kind of disappointed that ones we train leave and go somewhere else, and we have to train new ones. You can control what goes in the header, and in fact, you can group them together if you like. You can do all kinds of things. And this is a hook that you can use. Localization. Since not everybody speaks English, Lmod supports translations into Spanish, French, German, and a little bit of Chinese. And I'm always looking for anybody who knows any one of those languages wants to help translate the English into, the only one that's full, I think, is the Spanish and French. The German's not complete, and the Chinese is very inadequate. But sites can also tailor the messages to match, there's generic things like submit a ticket, but you might be able to say, submit a ticket at this website or whatever you want to say, and you can control that. We want to have accurate list of our module files, and since that's the gold standard, it's nice to have Lmod generate a list that can be added to your software pages so that you don't have to get it right once and then you start adding stuff and the web pages get out of date. Okay. I have a colleague which told me I should never mention the hierarchy because he's afraid that you're going to get the message that Lmod only works with the hierarchy. So sing after me, Lmod supports flat hierarchies as well, or flat layouts as well. But the problem is, as I pointed out, with parallel libraries and compiler-dependent libraries, So PETC is an iterative, parallel iterative package, and it's an example of what can happen. So if you have 2 compilers and 2 MPI implementations, you're going to have 4 versions of PETC of this 4.1. So a way to name it would be something like this, PETC, and the version, and then the MPI stack you built it with, and the compiler you built it with. So you got 4 versions, and users have to figure out which one of these things to load. So with a flat naming scheme, the user has to load the Intel 17, load the package that worked with it, and then load the version of PETC. And changing the compiler means unloading all 3 modules and then reloading what you started. And not loading the correct modules can lead to mysterious failures. It might work kind of some of the time, but usually doesn't, but it can fail in mysterious ways. And the onus is on the compatibility is on your users, or if you use a tool like Easy Build, and I don't know I guess SPAC does as well, can write complicated module files for you, but doing it by hand is just a nightmare. Okay. But you can have a hierarchical scheme, so you can have core packages, compiler packages, and MPI packages, and the user loads a compiler package, they see the compiler-dependent modules, they load an MPI stack, they see the compiler and MPI libraries that are available. So this way, you can do it either way. Okay. You can use either way. One of the nicest things is a user said, okay, I'm going to provide the old stuff and I'm going to leave it. And it just stays that way. And if you want, but all the new stuff is over here in the new layout. And so users can decide when they want to migrate. You just have a separate module path, you have a command that changes the module path, and all the new stuff is over there. Found it to be a very convenient way to move users rather than forcing them to say, okay, next Tuesday, you got to do everything different. Okay. This is a pet peeve of mine, and I'm trying to build a community around this to get to yell at the maintainers of Bash. So you'll have to put up with this for a minute or two. In my view, the Bash startup is broken for non-login interactive shells. So Red Hat, CentOS, and macOS don't source any system file on those non-login interactive shells. And the problem is that MPI jobs start a non-login interactive shell, which can be a problem. I want modules to work in all shells. The next one okay, so the next issue was, for us, our machine Ranger, the default shell was C shell because we had problems with Fortran users Fortran 90 users who needed stack size unlimited, and there was no way that no system file got sourced, and so their jobs would abort. But whereas if they were C shell users, it would work because C shell has a different startup mechanism. And we patch bash to source, et cetera, TACC bash RC because we want to control the startup behavior rather than getting the system to replace that behavior. So your choices are switch all your users to Z shell. Now that's my choice because tab completion on Z shell is way better than bash. You can patch bash, which is what we also do. We patch bash so that it sources, et cetera, well, in our case, TACC bash RC. And this is what Ubuntu and Debian systems do. You can expect all your users to source, et cetera, bash RC in their personal.bash RC, which is what Red Hat gives you by default, but I can guarantee you at least one of your users will get this wrong. Or you can expect all your users to start their job scripts with bash -l. I don't like, that's why, and I don't trust users. So, that was my rant, I apologize. Debugging Lmod. Lmod has more than 10 lines, so I'm sure it still has bugs in it. So I need to know what's going on your system. So Lmod, you can write it. There's a way to get the configuration, and there's a way to get debugs. So you can send me what happened on your system, and I can try and figure out what's going on. That's been very convenient, and it allowed me to grow the community because I can support the bugs that show up. Recently, Pablo was one of the first people who asked for this, ability to trace what was going on. So Lmod allows you to trace what modules get loaded, and you know which one was loaded because there's indentation, so you can trace loads, how loads and restores work, as well as what Spider's doing. Okay, so this has been really handy for debugging lots of issues. We had a user which had a group of users had pretty much the same startup behavior, but one of them got different modules than the others, and it was a little hard to figure out. It turns out one of them had a collection, the others didn't, and so the module path changed, so they got a different, that was why they got different. And I had to look at it for a while and said, hey, I don't want to have to do that, so I added tracing to make it so it was available to everybody. Okay, so this is a list of features. The other features, you know, I talked about most of this stuff, the families, semantic versioning, properties. I didn't talk about ML, but I've got collections, hooks, and nags. Okay, and oh yes, and remember again, it reads TCL and Lua files just equally as well. And the one name rule. So here's where you can find information about Lmod. The latest version is at GitHub. The stable version is at SourceForge. There's documentation at lmodreadthedocs.org. And there's a mailing list, and you can join there. Okay, so that's Lmod. I'll take any more questions on Lmod before I switch to XALT. Well, you're all experts, so we don't need to go further. Okay, XALT. So XALT is this project that somebody came into my office and said, hey, I want to know what's running on our system. And since I had done Lmod and Spider, I could do something I thought was interesting. LDD, if you do LDD on an executable, you get lists of shared libraries that are linked with that executable. That gives you very long paths. And, but that's not the way we think about it. We think about, okay, somebody's using PETC or MKL or some other package, so we wanted to be able to map that back. And so with the Spider, I also had the list of directories that are associated with a module file, and so we could back out from directories to module files. So that's really the impetus that started this thing. XALT is what runs on a system. It tracks, it's a census of what programs and libraries are run on your system. It's running at TACC and NICS and University of Florida, at KAUST, and a bunch of other places. And it integrates with TACC stats if you're interested. Design goals, it was to be extremely lightweight, provide provenance data so we could tell you how your jobs were run. We wanted to track what libraries and what applications were being used, and then collect data into a database for analysis. So I have to be in user space. I have to add something to your program to get it to link in. And so we have an LD wrapper which intercepts the user link line. We add a little bit of key value pairs to your code, capture the trace map output from LD, and collect this data into a JSON file so we can know what shared libraries and what static libraries were built with your application. XALT 1 required a wrapper for the things that initiated your MPI jobs. So app run, MPI run, IB run, whatever. And hooray, XALT 2 no longer needs to wrap these MPI launchers. And XALT 1 was tied to just tracking MPI jobs. XALT 2 can track anything you like. There's three ways currently to collect the data. You can use files, you can use syslog, or you can write directly to DB. And in future, I'm planning to support RabbitMQ. You know, this is essentially how this project started. And I talked about this, that Lmod Spider walks the trier module tree, and I can build a reverse map, which allows me to map directories into module files. And we can also do function tracking, so we can say these functions were used from these libraries. And sites that use tmod can still use Lmod to generate the map. But the data is big, and these join tables can get very large. The run join entry had 2.1 billion rows. I thought a billion was a big number, but it turns out it's not. So I'm looking at ways to cut down on the environment. The environment really is for reproducibility, but in the entire time that we've been collecting data, nobody's ever asked for whether an environment variable is set. And I talked to somebody else who's running the precursor to this, and they only had it one time. So things like storing the complete environment in a compressed blob, filter the environment with an accept test followed by, so I can reduce the number of environment variables from 250, on average of 250 to 20 or 30 or less, and the filter is site controllable. I'm looking at ways to cut down the size of the table by partitioning it by dates or by index and pre-compute things nightly so that you can get fast access to this stuff. One of the things that I learned more about is UTF-8. A user had put, in Texas, had named a directory with an N with an anye on it, and that messed everything up for me. So I had to learn way more about UTF-8 than I ever cared. Switching XALT to use prepared statements, and so I can avoid the, prevent SQL injection, sort of somebody has a program named Johnny Drop Tables and I'm in trouble, and support the UTF-8 characters. But XALT 1 uses Python, and while Python is a wonderful tool, except when I'm using it apparently, it's hard, I think it's impossible to protect a Python script in every user's account to protect the Python that I have from what they do. And so I have switched from using Python to C++. That way I can control the environment, I can control LD library path, I can control the path to control what executables get called. And I've hard-coded every executable that I use at configure time, which has one downside to it. If you're in a shared home file system, you're going to want an implementation per cluster, not per home file system. Because programs move around. Sometimes, like base name is sometimes in bin, sometimes it's in user bin. So, okay, I'm collecting this data. What the hell good is it? So yesterday's talk was, one of yesterday's talks was how to design a machine. And so one of the things that we've been very happy about with XALT is the fact that we know what people are running on our system. We know not only what programs they're running, but what percentage. So we do a lot of chemistry, more than I thought. I've learned all kinds of things, like we spend all this time providing applications, and only about 25% of what I call SUs, core hours, are written by or run using applications that we, the staff, built. So 75% of the machine's SUs are executables built by users. Then there was another question that came up, was how many, there's the Jim Phillips version of NAMD, and lots of people use it. And we wanted to know how many users were running programs built by a different user. And that's still like another 20, of the 75%, 25% of those are running executables built by some other user other than us. But that still means over 50% of the SUs that are MPI jobs are built by users. So yes, we still have to teach users how to build stuff. I thought if they were all using applications that we built, we could stop doing that. But that's not the case, at least at our site. I know about things like how many programs are written in Fortran. Well, let me rephrase that. I know how many programs the main was linked in Fortran or C or C++, and what compiler was used. And yes, Fortran's still not dead yet, at least not at our site. What else? Oh yes, targeted outreach. So one of the problems we had was the large mem queue. Our director was looking at the length of the time was in the large mem queue while he was waiting at airports to try and cut down this size. So we had a crisis on our hands, because if the director's concerned about it, something everybody has to hop to it. So we discovered that a particular chemistry code was a lot of them were being run in the large mem queue. And based on TACC stats, which is a tool that measures memory usage and size of memory, we knew that while they couldn't fit in 2 gigs, they could fit in 4. So we were able to say, look, you users that are running this chemistry code can move back to the regular queue. You just have to, what we call reduce weightiness. Instead of using 16 cores, use 8 cores and get double the number of memory, or half as many. And so we were able to reduce the size of the large mem queue from 4 days to 2, and that made our boss happy, so everything was good. Okay. So XALT 2 no longer tracks, or XALT 2 tracks both MPI and non-MPI jobs, which is, because I know that at least 25% of the SUs and 50% of the jobs are non-MPI jobs on our system. So, and I'm sure that your sites are doing even more scalar jobs and less MPI. So we used to only track MPI jobs by hijacking MPI run or whatever. But now we use an ELF trick to track jobs. Yes, I'm showing some code, but it'll only be one slide, so we'll survive. The cool thing is that these 2 arrays are built into ELF, and you can add things to them. And so you can have code like this, and you can add it to this array, and it gets called. So the init array gets called before main executes, and the fini array, all the functions there get called after main completes, assuming you get that far. And so this is nice. The C code, this is C code, which is linked in through the hijack linker. You can also set LD preload, or there's /etc/preload if you want to make sure everybody runs it. We're using both because I worry about users which will set LD preload and not add my stuff into it. And it's set up so that it won't, it's set up so that it won't won't count things twice if both are available. There are some downsides. We only track, to cut down the amount of data, we only record information from task 0, which means that we don't get the MPMD job. So if you've got an atmospheric tied to an ocean code, which is also tied to an ice code, you're only going to get one of them. And we don't know what the exit status is. The challenges are, the good news is that XALT now tracks non-MPI jobs. The bad news is it's tracking everything, every executable. So I don't want to, there's a lot of stuff I don't want to track. I don't want to track things like copy and move. I want to only track executables that are on the compute nodes, and I don't want to get overwhelmed by the data. So XALT can be told to track only what it's told to, compute nodes by host name filtering, executable path, or executable filter based on path, and this is all site configurable. So there's an accept test followed by ignore test. So you can say, I want to track, say DDT is in user local bin, I want to track that one, but I will ignore everything else in user local bin or SBin or whatever. And so you can say, or I only want to track things that are come from a user account, or in our case, a work account, or a work directory or a scratch directory. XALT 2 is gotten a great deal of hardening. We've been running it, this is a little old, I've been running it for about 8 months, and I've only got 2 tickets. So I'm very happy with that. I'm also working on, I don't really care about how long XALT takes on an MPI job. If you run an MPI job for a second or 2, and I might add time to it, I don't care. But
but we have lots of jobs that are parameter sweeps, so they may be short, so I want XALT to be as fast as possible, so what we call launcher jobs. The most expensive operation turns out to be taking the SHA, one of the shared libraries. So I switched it to be threaded, and now it takes 0.04 seconds on a Lustre file system, so I'm pretty happy with that. I'm running out of time, and I won't bore you with the demo. Here's also documentation on Lmod and XALT. Thank you very much.
So, well, I'm using XALT and Lmod. The way around to bypass this a lot of information that you can collect from XALT was, in my case, to use the wrapper, the LD preload inside the srun prolog. So this way, you only connect the data that is compute intensive, that needs to be through srun. And because serial code are also using srun for all the users, so it's more or less complete.
Sure.
But you, as you said, you never have to test the users. So some users may not use srun as a mandatory requirement in the HPC facility. So.
Oh, and one of the things that I'm looking toward is collecting. So right now I know about shared libraries, and I know that you have run Python, and I know that the shared libraries that were linked in, they're built-in LinkedIn. In other words, not the ones that are loaded dynamically. But I'm looking to add to R, MATLAB, and Python the ability to know what packages got loaded as well. I've got it. When I get back, I'm actually talking to somebody who knows R, and we're going to look at hooking that. And there's a way to do it in Python. MATLAB, I'm sure there's a way to do it, but I haven't looked at that yet. But yet, even more data to collect. Oh, and for XALT 2, I've got a configuration so that if you don't want to track, you can set it up so to only track MPI jobs if you're being overwhelmed by the data. Somebody had asked me out in the hall one time, you know, what kind of back end do we have? And we only have a single VM which holds this data. So it's not a big computational requirement to support the data that's being generated by XALT, although there's a lot of data. So I'm looking at ways to, I think that I'm only, instead of trying to store something in the life of a machine, I'm going to try and store just a year's worth or so, because any more than that's just way too much. I mean, Stampede 1 was 6,400 nodes, so that's a lot of data.
So it's Elasticsearch, what you have at the back end?
No, I'm using I mean, you can. Kenneth and I set one up in a day. You can use anything you want because you can set up XALT to write JSON to syslog, and then you can just collect it.
Or if you have a JSON output file, you can just inject that thing directly to Elasticsearch.
Yes.
And with data mapping, you can reduce quite significantly the size of the database.
Yes, but if you want to know, I mean, typically, what I've read says that Elasticsearch gets a little cranky once you have way too much data into it. I think XALT, I mean, I don't have any direct experience. I was just listening to this, and I'm looking at other ways to handle this data. I'm looking to go to sampling. I'm looking to go to a lot of things just to get lots of useful information without having to be overwhelmed by it.
More questions? So, well, thank you so much.